We're going to be looking at inverse functions today and what they are. And what we want you to be able to do is find the inverse of a function or relation. Okay, a relation is a set of ordered pairs. So given this relation right here, we want to identify each of the following. What's the domain and what's the range? Remember that domain is your x values, your range is your y values. So here, our domain would be all the x values. And remember, when you have an ordered pair, the first one's x, the second one's y. So our domain would be 1, 3, and 5. And then the set of our range would be all the y values, 2, 4, and 6. Now, when we start talking about an inverse, or an inverse relation, that's the set of the ordered pairs found by reversing the x and y values. So if you want to find the inverse of the one we just, of the problem we just had, the inverse would be the same point just switched around. So if this is x and this is y, when we find our inverse, you're switching them. So now 2 would be our x, 1 would be our y. Okay, the next point would switch as well, and same with the last one. So now all our domain and range values have switched. This would now be a inverse. So inverse is switching the domain and the range of the x and y around. Okay, so on number 1, they want us to take these ordered pairs and graph them out to form a triangle. So let's start by doing that. So we're going to graph out the points indicated here. So the point 2, 1 is right there. The point 5, 1 is right there. And the point 2, negative 4 is right there. And if we connect them, forms looks like a right triangle here. Okay, so that would be what's right there. Now they also want us on the same graph to graph the inverse of this. Well, the inverse, like we just did, would be the same thing, but everything flipped around. So it'd be 1, 2, 1, 5. And if we switch the last around to one around, negative 4, 2. So let's graph those ones out and see what this one looks like. 1, 2 is right there. 1, 5. And negative 4, 2. And again, it forms a right triangle. And the shape of this is same as shape as the other one, it's just kind of moved. Well, the inverse, what it ends up being is a reflection. Remember last year you guys talked about reflections in geometry? This is a reflection over a line. Now the line is not up and down, it's not horizontal, it's actually a diagonal line. It's a diagonal line with a slope of 1 that passes right through the origin. Right here, this green line is the line it's being reflected over, and the equation of that line is y equals x. And the reason that is basically, what did we do? We swapped the x and y values in order to do that, so that makes sense that that would be the line it's being reflected over. So anytime you graph a reflection, it's always going to be symmetrical, or a reflection over the line y equals x. All right, so on the next little set of notes here, they want us to find the inverse of a function now. So an inverse of a function would be a function that would give us all the other values that we want, all the different y values. But the idea is the same. We want to solve for the other variable. When we have a function f of x equals x plus 2 that we have here, remember, f of x is like y. So another way we could write this would be y equals x plus 2. If we want to find the inverse, instead of a y equals equation, we want a x equals equation. Well, to make this an x equals equation, we want to get everything away from the x. So we would start by minusing 2 here. If we do that, now our equation becomes x equals y minus 2. And that would be the inverse equation. X equals y minus 2 does the exact opposite of the other function. Now, there's a notation that you use when that they often use when writing an inverse, and it's this f negative 1. Okay, that notation means the inverse of f. So if we wanted to write that with the same equation we got here, the x would turn into this notation of inverse. And then instead of y, we would swap it with an x. So the inverse function would be written like that. Now, if we wanted to evaluate any of these, all we'd have to do is plug a number in. So if we want to evaluate what's f of 5, we've done those problems before. That's just plugging 5 into the original function that we started with. And it looks like that would equal 7. Okay. Now, if they wanted to evaluate the inverse at 7, we would want to start with this new inverse equation we just got and plug in 7. And we get 7 minus 2, which equals 5. Now, it should equal 5. And the reason is, okay, think about what we got over here. When we started with an x value of 5, we got a y value of 7. In other words, 5, 7 was an ordered pair there. If this is truly the inverse equation over here, we should get the same two numbers, just opposite. And here, when you plugged in 7, what came out? 5. So that means 7. 5 is a point on the inverse. And it's just the same 2 points swapped around, just like we were doing before. Okay, number 2. Once this again, find the inverse. So if they give you this f of x notation, my suggestion to you would be switch it to y, because we know f of x means the same as y. Okay, so now what we want to do is solve this for, instead of a y equals, we want to solve it for an x equals. We want the opposite variable. Okay, if there's division, start with that. We're dividing by 2. The opposite of dividing by 2 would be 2 multiplied by 2. So if we do that, now we got 2y equals x plus 6, because these 2's would cancel out. All right, we're not quite there though. We don't have x by itself yet. Next step, we want to get that 6 out of there, minus 6 to the other side. That cancels out. We got 2y, take away 6 equals x. That is now the inverse equation. Okay, so our inverse on this one would be x equals 2y, take away 6. If you wanted to write it with that function notation, the inverse on this one would be 2x minus 6, and we just swap the x or the y with an x. So that's okay. That would be the best answer. This would also be the inverse though, because it does the opposite of what we started with. All right, let's try another one of those. Number 3. They want us to find the inverse of this one. So again, f of x is like y. So we want to get this to be an x equals equation. How do we do that? Move everything away from the x. Here we'd want to start by subtracting 10. That's down now, so you got y minus 10 equals 5x. Now to get that 5 out of there, to be multiplied, opposite of multiplying would be to divide. That cancels out. So now we have x equals y minus 10 over 5. And that would be a good answer here. One other thing you could do, or another way you may see this, since we divided by 5, we could also think of this, instead of dividing the whole thing by 5, we could individually divide these by 5. And you could see that answer maybe like on the ACT as well. Okay, you could divide everything by 5. So if we did that, the answer would be x equals, and now this is going to be the same thing, just look different. We want to divide here. Now the y has a 1 in front of it. If there's no variable, we know it's 1. So this would be like 1/5 y minus, and then 10 divided by 5 would be 2. So this answer is saying the same thing as the one above it. It just looks different. Okay, it's the same, just looks different, but they both would be the same thing. They're both equivalent. They give you the same answer. Those same two answers written in that function notation would look like this: f at -1 equals x minus 10 over 5. And if you did that second one in function notation, it would be this. Okay, so both of those are the function notation. All right, number 4. This one now they want us to determine if this function f and this function g, are they inverses of each other? Well, do what we were just doing and you can find it out. Let's start with f. Okay, let's change that f of x to y. So if we want to see if this is an inverse, let's solve it for the x, which I forgot to write. There we go. Let's solve it for the x. So this one, start. Looks like we want a plus 6 to both sides. If we do that, now it looks like this. Okay, now we want to keep going. This is being divided by 4. So let's times both sides by 4. Now when we times that other side by 4, there's two things here. We're going to have to multiply both of those by 4 here. So these cancel out. We got 3x left on that side. Over here we're going to have 4y plus 24. Okay, now the next step, last step, we want to divide here by 3. Let's divide everything by 3 and see what we get. So we end up getting, that cancels, x equals 4/3 y plus 8. So we want to check, is this the inverse of what we have here? And it looks like, yeah, it is, especially if we write this in that function notation. That function notation would say that this is 4/3 x plus 8. And yes, that is the same thing. So yes, these two functions are inverses of each other. If you get something different, then they would not be inverses of each other. All right, let's look at another problem. What's the inverse of this equation? You guys have seen this equation before. This equation, a equals pi r squared, is the area of a circle. Okay, so that's the equation for area of a circle. They want us to find the inverse. Okay, well, what's the inverse? Inverse would be, instead of an a equals equation, we want to solve for an r equals equation. All right, so how do we get, in this problem, how do we get r by itself? Well, first thing we want to do, looks like, is divide by pi. Get that pi out of there. So now we got area divided by pi is equal to r squared. How do we get rid of power 2? Remember, inverse or opposite of that is the square root. So square root both sides. And now this side's just plain old r, and r is equal to the square root of area divided by pi. So that would be the inverse. And what does this inverse function tell you? It would tell you what the radius is if you know the area. So if you knew the area of a circle and you plugged it into this equation, divided by pi, take the square root, you tell you what the area is. So we could use that. Let's look at this problem. Find the radius of a circle whose area is 314. Well, we can find that out now. Plug that 314 in for a and see what we get. So the radius would equal the square root of 314 divided by pi. So now put that in your calculator, see what you get. So if we did square root of 314 divided by, we'll use our pi button here. Looks like it's about 9.997. That looks like, to me, it's pretty close there to, radius is pretty dang close to 10 centimeters. Okay. Next one, number 6. The formula used to convert degrees Celsius to degrees Fahrenheit is shown. Find the inverse of this function. Okay, so we got this equation, f equals 9/5 x plus 32. We want to solve for x. So first thing on this one, and I'm going to switch to this here. This is, x in this problem is the degrees Celsius, so I'm going to use a C instead. This degrees Celsius is what you're plugging in. So we want to solve this for C. So minus 32 from both sides. That cancels out. So now I got F minus 32 equals 9/5 C. Okay, now we want to find out what C is. So we got some division here. We could times both sides by 5. Now again, you got two things there, so you're gonna have to multiply them. So we got 5F, and we got to see what 5 times 32 is. Looks like 160. Okay, last step now. We got to divide by that 9, so we got to divide the other side by 9. So it looks like our inverse here is C equals 5F minus 160 divided by 9. And I'm not going to divide those individually because I don't think 9 goes into either of those. So this would be the inverse of the other one. And what can this inverse be used for? Well, exactly what it says. Now you have an equation that you can convert degrees Fahrenheit into degrees Celsius. So on this one, if you wanted to convert, you could plug in whatever your degree is in degree Fahrenheit, and you could find out what that would be in Celsius. For example, maybe you're on vacation, and you want to make sure it's at least like 85 degrees out or something if you want to go out on the beach. Well, you could figure out what 85 degrees Fahrenheit is in degrees Celsius by putting into this equation. So if you did 5 times 85 degrees Fahrenheit minus 160, which is that, and if you divide that by 9, this would convert it to degrees Celsius. So 85 degrees Fahrenheit is like 29 degrees Celsius. So if they said on the news in the country you're in is going to be 29 degrees Celsius, you should know that's going to be pretty warm. Okay, I want you to try some of these out on your own now and see what you get on the